Hello, welcome to the next Nix Hour. Today, we got a question asked here in the meeting. It's about, well, otherwise we'd be going through the issues here, and probably we will after this question has been mostly answered. But feel free to open your own issues in the Nix Hour repository here and upvote existing ones if you're interested in them. But so the question we were asked today is, sometimes packages use multiple languages. In this case, it's that we have a Go package that's needed to build the Python package. And in this case, there's multiple components here, apparently, multiple plugins. But let's just focus on this one to see how that might work. So to start off, I'm just going to clone it here. Nix Hour clone in here, and this doesn't work because I need to clone this. All right, and then this in plugins. What's up? All right, so we have go.mod and go.sum for Go packaging. This uses some dependencies. Okay. We have we don't have a Python dependency file here. I guess it might be in the tree here. Oh yeah, we have poetry file, a Py project. What's up? Let's see. Okay. So I guess these are the Python dependencies. And so Go has to be compiled first. What does Go do here? Maybe let's read the README briefly. Installation, containers are available, debian, privacy, PyPy.
If you're looking for build instructions, you could look at the Docker file, which is written basically in the spirit of do the Python thing, then do the Go thing. But it's not as straightforward as in NixOS because build Python application and build Go module are different things. That's one thing. And another one that it wants network access during the Go phase.
So it does Go, Go Py. What is Go Py? Oh, Go Python. So there's apparently this project. Let's briefly also take a look at that. GoPy generates a CPython extension module from a Go package. I see. So I guess it generates. So we could maybe try to. So I guess the output, I believe CPython extensions are shared libraries. And that's then the output of this part. But you said it requires also network access, so that won't be super great. So generally in Nix, if something requires network access, the kind of only and best way to package something like that is to just try to patch it to not do that. And in many cases, this just requires digging into the tool that actually does the fetching. In this case, that might be Go Py here. But this looks fairly complicated. I don't want to dive like fully into it, but let's try to look at, for example, one example in Nix packages where this might be done. So to find this, let's try searching for, let's search for build Python application. But then I'm going to, with riprep, you can include context. I'm going to include 100 lines, or let's say 200 lines. That in the context, I'm going to grab for like, let's go the other way around, build Go module. I think that's a bit more common, and then Python. Okay, so we have a couple here. Source Hut, I know that was really hard to package. Oh yeah. So let's just take a look. Build Go module. So there's a whole bunch of Go modules here. All right, and then is there also a Python? What is a Python used for? It is used in all of these. Okay. Now that's Python. Oh yeah, we have actually two calls here. Build Python package that does it like this, and build Go module is actually not used. Oh, it is used here. So yeah, I guess here in this case, it just does multiple derivations. And once it built the first one, I guess it passes it as a derivation to the next step. In this case, I see that the dependency is on a binary itself. If you have a shared library, it will be a .so file.
Okay,
Yeah, so
so
this is
the
pretty
idea
tricky.
is that I should have a build Go module and a build Python application, and then another derivation that merges them together.
That is a way to do it. Yeah. So these builders, all of these builders are, so they do make it easier to build a lot of things, and they do abstract a lot of behavior. But it is also possible to just kind of extract that behavior into a single derivation. So for example, if we look at, let's look at build Go module equals, all right, build Go 199. Oh, actually, I think it's the joy of trying to find a definition. 9 module. Okay, let me use this trick. 9 module. There's also multiple builders. So this is, this is for, okay, this is an interesting pattern. So I believe this probably is the same as call package, but it also has Darwin specific packages in it. But that's a bit weird. If we go into Go module here, let's look at this. So underneath it, of course, all of these builders underneath are a stdenv.make derivation, and they all pass some arguments to it. They have their own hooks and phases and so on. Now, they do have a lot of like different behavior here. So we have when you enable proxy vendor, then it does something else here. And for a specific package, you will only ever need one case of these, probably. Same here, we have some install, it copies some files around. These are like fairly simple operations in a lot of cases. And so if it really doesn't work that we have multiple derivations, I think you could also copy these instructions around into a new call to stdenv.make derivation that does the same things. We could also, let's try this out here with, let's go into Nix packages and let's search for a build Go module. Lots of them. Let's go into here. Okay, that looks like a fairly standard one. Now let's see how far we can get by just changing this to a make derivation. And let's first remove all of the Go specific things here. Let's remove actually that and that. So this will definitely not work. Because by default, so stdenv.make derivation by default calls make and make install and /configure in the beginning as well. Go packages don't have that. So if we try this here, next build-a my core hisa. Yeah, it fails. It probably fails with, go command not found. So something in here.
It has make file.
Yeah, so apparently it still has a make file. in Nix, we usually override the make files with our own build instructions. Let's take a look at the make file here. So I built the source, and I'm going into the source here. Sometimes the source is a tar or another archive, then you need to unpack here. In this case, it's not, so we can just go into here directly. Yeah, it has a make file, and to build it, it does this, and yes, it calls go generate. I'm not actually sure what go generate does.
It
But yeah,
runs a bunch of commands that you can specify in Go sources and that usually generate some other stuff.
I see. And yeah, then it calls go build. This is usually the step that's specified in Nix instead. So if we go to the implementation of build go module, I lost where that was. Let's do this right here. So if we go into here, we should be able to find so there's a bunch of environment variables, configure phase, so it goes to the mod root. So I mean, the phases is what gets run in the end. And here we have things like go cache. We could copy these over. Let's do this. Let's do configure phase, or let's actually do post configure, so we don't override the. Actually, the configure phase doesn't work. It might. Well, let's do it here. Let's copy these over.
I think what you have on the right is to generate modules, not.
How did we?
Not the build the app itself, but
it is the build go module.
But
I
think it uses that vendor thing, which is a separate derivation, and I think you're looking at that derivation, not at the one that actually builds the final.
App. I see what you mean here. Yeah, so there's the Go modules here, which builds the vendor. Yeah, good point. Thanks for pointing this out. Well, then I guess we need to dig a bit more into it. We have proxy vendor. Is proxy vendor set by default? I don't know. So it is a fairly laborious process, I'm just realizing. Proxy.
In just on the high level, what does this vendoring derivation do, and how does it do it without the network access during building? Or does it have one?
So here we can see this here, the vendor SHA-256. And yeah, actually that's a good point. So in Nix packages, there are some builders which do this. And what they essentially do is they make a fixed output derivation, meaning you have access to the internet and can fetch stuff. And then after the first time you run it, you set a fake hash, right? Something like this. You get the right hash back, and you can set this, and then this then works. The kind of problem with this is that it's very tool dependent. Like the tool needs to ensure that you always get the same result, and we can do like anything like this. So just to demo this, let's do a demo.nix, sure. Our generic import of Nix packages as always. So let's do stdenv.make derivation. Yeah, and then let's do build command. And then let's fetch something. So let's do github.com, sure. Let's do a curl. So let's add native build inputs equals packages.curl. And let's put this to the output. And then this won't work by default because it's not, right, we run in the sandbox. Let's do demo.nix. Derivation name missing, name is test. All right, yeah, that fails. And so now let's provide an output hash. So let's set this to empty. I believe this might already work. Empty hash requires explicit hash type. Okay, put hash type, I believe. Output hash. Hold on, output hash. I'll go. Okay.
I think we should change that error.
Yes, definitely. So we don't have CA certificates. Fair enough. So let's add those. CA certs. CA cert. Okay, now it works.
Oh, so just specifying output hash and output hash algo has disabled the sandbox.
Yeah, well, it disabled. It didn't disable the entire sandbox, so we still can't access like my home directory here, for example. But yeah, it allows fetching. Yeah,
Okay.
but so in this case, this works, but it's not great because, of course, GitHub changes every time. Probably if we fetch this again, it's going to fail. Let's try this. So currently it works. But if we try it again with, let's use -- check. Yeah, we already get a different hash. And that's kind of the contract you have to sign when you make a fixed output derivation, that you make a guarantee that it is always the same result. And this is why that's kind of how Nix achieves or pretends it's pure, because it always gets the same result by definition. But then in turn, right, you need to be able to guarantee that.
Okay, so on a high level, when I wanted to build a derivation which is a mixture of Python and Go, first I separated into Python and Go and try to merge them. And if it's not possible, try to write a combined build Python and Go thing. And on the Go side, there was this code generation thing, but I'm fairly sure that the code generation will have a result which is fixed and doesn't change over time. So then I can use this trick to run my tool which wants online access, then get my generated Go files, and then build them with build Go module. Okay, I think I have all the building blocks. I have all the building blocks I need. Thank you.
Yes, it's. I mean, there's no unique best solution for everything, depending on like how well you can reuse the existing builders and what the results from each individual build are. It might be easier or harder. I think in this case, yeah, you can use first Go to build the shared library, and then like we saw in the package before, just kind of link that or reference that dynamic library path from the Python build. And yeah, you can use this trick to make it work if it needs internet access. This is generally discouraged unless, well, better would it be to like lock inputs in Nix itself. So we can sometimes see this, I think, with Perl or gem file. Yeah, so like npd cron. Like this, if possible, we encourage doing it like this, where you, in this case, yeah, it's probably good, where you kind of try to parse the log file or whatever or not even the log file, just the dependencies, and try to lock those in Nix, so we can be sure that we have each individual dependency and can fetch those kind of out of independently. And so each of these fetches here gets transformed into like a fetch URL call or fetch GitHub. And yeah, this way we can be sure, yes, URLs generally, if they are kind of hashed and they have a version, they return the same thing, and the fetchers make it work that way, then it works pretty well. Yeah, another brief trick. I remember this from I believe Clojure. Actually, I can show this briefly. So I wrote this small project a while ago to package Clojure projects, and how it works is very simple. It's essentially so let's look at it here. It's a very simple Python script that goes through the home directories .m2 repository directory, and so this is where Clojure and Java as well puts all of its fetched dependencies. And so from this, I can very easily create a log file by just reading all of the files, hashing them, and writing that to a JSON file. So that's what this code does. It's just like 60 lines of code here. It generates like a shell, like a Nix, almost a Nix call. Yeah, so in total, how it works is that it creates an empty home directory. So like in a derivation, it creates an empty home directory. Let's see. Oh yeah, here, create home. Actually, no, that's the reverse. So this is what assembles the Nix derivations again. So here it parses the log file that was generated, and then writes that, or then passes that to fetch URL. But we have also is it here? No, is it here? Yeah, I believe this. So in this case, it kind of wraps the actual generator with a different home directory. So it's empty at the start. And so then you can run, like this is impurely before you actually build the thing in Nix. You can run it. You can let it generate all of the files in the home directory. And then after it's done, we run our tool on that home directory, which parses all of the files, or not parses, which hashes all of the files and writes them to a log file. And then you can commit that log file to nixpkgs or anywhere else and kind of reconstruct the home directory in the Nix build then. And that's another technique that works fairly well for a lot of cases, and it's more pure and more safe than this vendor SHA or cargo SHA-256 as well, which is just kind of builds the whole derivation, and then user has to ensure the hash matches. Yeah, so
I guess we have shifted from how do I build this thing to how can go build module be a better thing.
yeah. And for honestly, for all languages and frameworks, there continue to be new tools and so on. And so for Rust, I believe there's like 5 or 6 tools already, and they keep getting better and have different trade-offs and so on. So yeah, it's not easy. Oh, and of course, let me also mention Dream to Nix, which is kind of an effort to kind of unify all these different Nix tools into a more common interface. I believe the general idea is there's log file generators and log file readers, and various different tools can generate them, but it's a shared format. So the log file kind of stays the same across all of these different generators and readers. I think there's names for these. But yeah, that's a very nice effort, though it's unstable at the moment, but it is being developed in like a couple months.
Is it something to be used directly, or is it just some code shared between those 2 Nix things?
It is something to be used directly. So I believe examples. Yeah, so they already have some examples here. So like it's called Cabal, and if like example, yeah. Yeah, so it contains all of the kind of infrastructure or the tooling that you need. Yeah.
Okay. I think I got my answers. So unless you want to bring up something else, you can switch to other questions.
Yeah, glad to help. Yeah, so I do see that since last time we've had a lot of upvotes for this bootstrapping process of stdenv, which I don't know a lot of things about, but I just refreshed my memory recently a bit, so I can talk a little bit about this. Honestly, almost nobody knows about this, so maybe I can even just help some people get started to like which files does it start in and how to look into this. Yeah. So we go, as always, into Nix packages. And actually, what do I have here? Oh, that's fine. So yeah, bootstrapping of stdenv files. So to start off, what is stdenv? stdenv is the thing that contains make derivation, which is used to build essentially every derivation out there. And make stdenv comes with a certain number of tools available by default. So if we go in, let's do a nix shell-p without any arguments, that gets us into like just make derivation shell without any extra packages. And let's an alias nix shell because it's alias to C shell. And so in this case, let's look at path. And we can see a lot of examples here. Let's replace colon with new lines so we can see the individual packages. Yeah, so we have bash, we have patchelf, GCC, a lot of utils. We have some output input processing tools, and a whole bunch more. This is not by default, and these actually, I don't think these should be there by default. I think, yeah, probably on these are added. Actually, we can check this. We can do this with pure. Yeah, so it's these tools. And so the question is, where do they come from? Because we can't really use the default stdenv.make derivation to build those, because that would give us infinite recursion. We also have some comments on the YouTube stream. How I get auto completion for Nix packages attributes in Z shell. That's, I think, there's a Nixverse option for this. If you go C shell compilation, yeah, I believe this installs the completion by default, which works pretty well. Also, same options exist for bash, I believe, or maybe Nix has completion there by default.
And the same exists in Home Manager.
Yes, Home Manager also has these options. Bootstrapping, yeah. How do we get to that? And what is a starting point? Like, where does Nix packages start off with anything, really? Yeah, so to start here, let's go into stdenv. So packages/stdenv, that's where most of this is. And yeah, this is actually this kind of how stdenv is defined. So if you go into here, first file here, first of all, it switches between different systems. So for Linux, it's this one. For cross compilation, it's slightly different. For Darwin as well. So in this case, Linux is used, /Linux. There are a lot of extra things in here, which I believe are, to the most extent, just kind of deprecated and not used anymore. So yeah, let's just focus on the Linux one. And yeah, so in here we can see Bootstrap files. And so these are the actual files that are used to start off. So if you go into x86 64 here, we can see this. And so yeah, some things here. So we have Nix fetch URL. What is this? I mean, this, I believe, even exists in Flake, but it's a Nix path reference. But if we go into, I mean, this evaluates, let's go into Nix REPL and do nix fetch url.nix. This returns a kind of weird reference like this. We can also look at built-ins.nix path, which then contains all the entries, but it doesn't actually show up there. It's like an internal Nix path entry. And so this, where it's defined, that's defined in the Nix source code itself. I believe if you search for fetch url.nix, yep, it's in here. So this is a derivation builder in Nix, and it uses this kind of special built-in builder here, which internally, I believe Nix just uses curl or some fetcher library to do this. And this is where we can start off at like actually fetching more things from the internet. And this is a kind of more basic fetcher than the built-in fetch URL. It doesn't have all of the niceties. Yeah. But yeah, so in Nix packages, this is used, stdenv, Linux, Bootstrap files, and here. So yeah, this is used to download Bootstrap tools. And so this is stored on tarballs.nexus.org. I believe this is just the kind of Hydra cache as well. I think at least. And so someone has to upload this or make this be built and change this hash at some point. And this, I'm not sure how often this happens. We can look at the commit history here. Let's do git log patch. And okay, with some tree-wide changes. Okay, 2020, they were regenerated the last time. From Hydra's binaries for this commit. Okay, they were retested. Okay, that looks good. And so this is good. Let's also look at Hydra here briefly. Let's see if we can find the Bootstrap tools in here. That might be a bit harder to find. It might be Bootstrap files. So these are the actual files used for bootstrapping, but I believe in make bootstrap tools, they are defined. And so this can use all of the dependencies in Nix packages because it's just kind of a stepping stone. We use an older Nix packages to build a newer Bootstrap tools, which is then very self-contained and a simple and self-contained stepping stone for the next newer Nix packages. I do want to see, okay, this, we can actually build this ourselves manually here. Let's try this. Make Bootstrap tools. All right, that fetches it already. So yeah, I believe somewhere that's built. Let's continue on with that. And so we have these Bootstrap files. What they contain, let's look at that. Bootstrap files. Next, let's do it just very manually here. Let's copy this. Let's do a kernel. I did this earlier as well. So let's download these. Let's unpack the archive. I'm using a tool, a generic unpacking tool here. And let's go into here. It's a bit weird that the tar extension is still there. But yeah, in here we have, let's look at the binaries. out, oh, bin, ls bin. Okay, so here we can see we have a lot of things. We have bash, we have core utils, we have GCC, we have make. That's actually a lot of things that can be used in the end. But they aren't actually used in the stdenv we see in Nix packages, because all of these versions are probably fairly old, because they come from an older Nix package and they don't receive updates. So I guess if we evaluate this, so let's try tar -- version. Oh, and I guess I can maybe not even execute them just like this. File tar. Oh, yeah. So the dynamic interpreter was also set to just an invalid store path. I guess that's done so these Bootstrap tools, these Bootstrap files don't actually have any dependencies on anything else. Kind of makes sense. But yeah, let's look at the actual kind of bootstrapping now. I believe this is maybe in here. No. Generic, no. Well, I need to reorient myself here. And pure default. Then it goes into here. Stage, stdenv stages. So this is what we want to look at. You can also see is the stdenv definition here. It's not, I don't think. But yeah, so stdenv stages, that's what we want to look for. There's also some other kind of potentially confusing bits. We have stage here as well. That's something different. That's for assembling the overlay chain internal to Nix packages. But yeah, so stdenv stages, that comes from, oh, here. So that is the main directory here. I believe we were right. Oh, we need to go into the Linux directory. Fair enough. Linux directory. Okay, here. Yeah, I think we found it, where there's very nice to see a lot of internal documentation here to explain the process. And so this goes over this a bit. It explains the goals of the process. So, and that's what I mentioned earlier, that the Bootstrap files that are fetched shouldn't be referenced by the final stdenv, because probably they are out of date and you don't want to use them directly. And also nothing that is generated by the Bootstrap files. Might also be related to the same thing about the generated binaries and so on, not having the security updates and so on. So we also have some interesting things to look at in here. So debugging stdenv dependency graph, it shows us how we can use this to access earlier stdenv stages. And so how that works in general is that there are multiple stages, and each stage builds up on the previous one, and gradually adding more and more tooling and so on. And so the output of this file is the list of these stages. And we can see here, it starts off with a very basic stage here. Well, not containing anything. The next one here, oh, and why are these set to null? I believe that's done because a lot of packages, or we want to reuse package definitions, but if we just don't declare these attributes, we'd get an error that the attributes don't exist. Whereas if we add a null, they can be added to build inputs. So we can do this, and the dependency will just be ignored, and we don't need to kind of make sure that lib.optional attrs if packages GNU grep, then add GNU grep. So it's a bit easier to reuse definitions. I believe that's the reason behind this. And so we can see in the next stage here, we add overrides. I believe these are just Nix packages overlays. And we have an explanation up here. Build a dummy stdenv. We know GCC or working fetch URL. We need an stdenv to build these things. And it shows us what we have going out from there. And what does it use? It uses okay. So this is getting into the details, but we can see it accesses Bootstrap tools. It uses lib from there. It uses include glibc, no idea what that is. It also builds bin tools wrapper. This is just a shell file. Yeah. So over time, yeah, we can see here in this stage, we assign GNU-grep to the Bootstrap tools one. But if we go further down here, GNU-grep, so this inherits it from the previous stage. The next one as well. The next one as well. But in this stage, if we go back down here, well, this gets it from self, loud requisites, GNU-grep, kind of all inherits it from the previous stages. I do believe this does take into account the whole fixed point of Nix packages, though. Yeah. And so I think a bit more generally how this works is that it reuses the definitions in Nix packages, but the packages won't build with these. It would give infinite recursion if it would be just tried like that. So we set certain dependencies to null and override it in certain ways so that we can build without these dependencies initially. Here we have a very basic derivation. Let's look at this example. I think this is pretty good. So bin utils wrapped. I believe by default it wouldn't build if enable gold was turned on, so it's turned off, so certain dependencies disappear. Let's maybe look at this a bit more closely. Bin utils unwrapped, bin utils default. This looks right. Gold, enable gold. Or in this case, it's something to do with enable gold, has gold. I can't see which dependencies are needed in this case. Or it might just be that it's something with cross-compilation. But yeah, this is kind of where my understanding ends. I know the gist of it. We could also look into it a bit more with this. So in this file here, the stdenv Linux default, we have a lot of comments, and there's also some examples down here how to explore the dependencies of the stdenv. Let's start with just these kind of things here. So let's dig into this. Let's do a nix build-a stdenv at first and look at the dependencies with a store nix store-qr. Yes. Oh, you can see I did this earlier already to try it out. So yeah, this has a bunch of dependencies. That's the stdenv we know. But if we do boot packages.stdenv, this is the previous stage before the final stdenv. And so in here, well, it's a bit shorter. I can see this by not having to scroll as much. But if you go even more back here, still a lot of packages. Let's go back even more here. I believe there's like 6 stages or so. This time we can actually see the list, the full list without scrolling. A lot of these are just files. So Nix kind of copies these files into the Nix store and registers them as dependencies, but they aren't actual derivations that have to be built. So like this move docs, yeah, that's just a file in here that's just copied. So we have a lot of these, all these shell files, I believe. We do have busybox here. We have Bootstrap tools. I believe these are the ones we fetch using this nix/fetch url.nix. We have some glibc bootstraps thing here. We have zlib. If we go even further back, we will have less even. And let's go to the last one we can see here. Bootstrap packages. Oh, now we have stdenv. Okay, I guess this is as far as it goes. So in this case, we just have a lot of shell files. We have busybox, we have bootstrap tools, and we have this. And yeah, that's about how it starts, how we saw.
Sorry.
And in this case, actually, this barely contains anything. What about bootstrap tools? Oh, this is the one we saw earlier that contains all of these things.
Sorry, can I interrupt you and have like 5 minutes of time? That would be awesome because I'm like exploding. I just want to answer it in a different way. If the original question is how is it done in NixOS, then I think you did an excellent job on answering that. But the problem for understanding how to do that yourself is that in NixOS it's done in an efficient way, which is a bit hard to understand, and it's also super parameterizable and everything. So I once did what you did and found it very confusing, and I started 2 little projects of mine. I've pasted the link in the chat, and if you could open those, that'd be very great. So awesome. What I did, I took just one binary, a tiny CC compiler binary, and used it to bootstrap a better compiler, then a better compiler, then a better compiler. And then I reached Nix and started doing the same thing with Nix. So this first project is how to build better compilers out of simpler compilers. And it culminates with Nix packaging a C-lang toolchain. And then the second project is, it continues from there. It takes the C-lang toolchain and builds an stdenv out of it, also reconstructing some of the Nix packages idioms. And if one wants to retrace how it could be done, I would recommend looking through this because it doesn't use Nix packages. It doesn't try to be maintainable. It tries to be verbose, understandable, and serial. So I think one can just follow along and see how you can end up with an stdenv starting from absolutely nothing, not even Nix. Thanks.
Awesome. Thanks a lot. Yeah, that looks really good. I wasn't aware of this. Thanks for mentioning.
Yeah, I haven't actually marketed it in any significant manner.
Yeah. So yeah, I can actually, yeah, you can see the URLs here for the people watching. Yeah, so that's nice.
And it ends up with a bootable ISO, which doesn't do much, but still.
Nice. Awesome. Yeah, I wonder, I do have a slight memory of someone else trying something like this.
I actually had some person reach out to me and ask whether this bootstrap they can take this bootstrap and plug it as Nix packages bootstrap. I said yes, of course, but I haven't heard back from them. And this is even more hardcore people who start with just some assembly and end up with the tiny CC compiler.
This does remind me of
GUIX thing. Yeah, it's exactly this.
I see. Yeah, that.
I'm not that hardcore. I start with a compiler.
Yeah, and so Nix, I mean, Nix here is also not very hardcore at all. It starts off with all of these Bootstrap tools here.
Yeah, I
and
felt
that's,
like it's cheating.
yeah, yeah. Yeah, and there is actually some other things in Nix. If we look at, I believe it's Nix or import Nix config.nix. Oh, that might have disappeared actually. I believe this was a thing at some point. Config.nix. Maybe not. Oh, okay, yeah, it was removed at some point. That did contain some like bootstrapping tooling within Nix itself that you could actually use. But yeah, since that doesn't exist anymore, we don't need to talk about that. Yeah, so, well, I'm about out of things that I could mention about this. There are, I mean, I think Alex, you yourself probably have maybe more, probably more knowledge about this than me, since you created this entire project. You could probably also talk a bunch about this, but yeah, my knowledge kind of ends here. Oh, and you mentioned this here as well. That's nice. So yeah, but if there's more questions about this, feel free to open other tickets. I'll close this one after this Nix Hour. And otherwise, we might just have to get some other someone else than me to talk more about this if there's interest. Yeah, so I don't want to stretch it any longer than this. Again, feel free to upvote HDs you're interested in. Well, we do have time for questions if someone has some. Like,
I'd like to mention that I believe that some tool chains also do their own bootstrapping, right? So like Go is built from the alter Go, and it's also reflected in Nix packages.
Yeah. And
what's the name again?
Auto tools, or
yeah.
And that also reminds me of Nix's bootstrapping as well. So Nix kind of needs to make sure that it can be built without a Nix already installed, because, right, that's the bootstrapping problem. You could use an older Nix, but I believe currently Nix can indeed be built without Nix. And there's instructions for this. And we can also see a bootstrap.shell file here, and there's instructions to how to use that. I believe this is even in the stable Nix manual under a hacking section. Yeah, so git clone. Okay, this uses Nix. This actually uses all Nix. Oh, I think it's possible to do without Nix as well, and so that does restrict.
It sure is.
Yeah, that does restrict to some point what Nix can do, because in the Nix flake you can specify. Okay, I'm currently working on something here, but you can specify like boost.override and a lot of changes to it. But this then means that people that don't have Nix will have a much harder time to build it, because you aren't using a standard boost version anymore, or maybe the override is required to have a standard boost version. Could be either. But yeah, you want to aim for the least amount of changes to a standard, to the standard tooling in other distros as well. Yeah. But yeah, that's about it. Let's end it here. Thanks for